Okay, so once again, applying proportional reasons, you will see today in our examples, all the numbers that we are using aren't necessarily quote unquote nice. Okay, you can't look at the number and be like, oh, those are multiples. Great, I know what number I have to multiply. There it is. And therefore, I am going to, again, try to push algebra onto you in hopes that you will be able to get the unknown value x by itself through mathematical reasoning. And again, I'm going to try to show you, I'm going to model what I would expect your showing of work to be. Speaking of showing your work, all your tests are marked, but I will be giving them all to you tomorrow. I will also be giving you examples of what I would consider to be perfect showing of work. I didn't really take off too many marks unless one, there was absolutely no way I could follow your work without making crazy assumptions of what you're doing in your brain. So in other words, not mathematically conventional, or you didn't reduce properly. One of those two things, right? We'll talk about that a little later. All right. Algebra with proportional reasoning. And this is why I was constantly trying to push algebra onto you last week. Where's my annotation? Here we go. This is a photo of a father and his daughter. Why is this not plugged in? Because I'm stupid that way. In the photo, the father's height is 8 centimeters, as you can see, sort of. I'm not sure if you can see that, but that says 8 centimeters. And the daughter's height is 6 centimeters. The father's actual height is 1.8 meters. What's the actual height of his daughter? So a couple of things I can do. I can set up proportions based on picture versus real life. I can do picture to real life, right? I can also do, what's another ratio I could do? I could do the father's height to daughter's height as a ratio, right? There's so many different things. So let's take a vote. Who would feel inclined to create a ratio or a fraction between pictures, distance versus real life distance? We got one person. Who has a burning desire to do father versus daughter? One person. Yeah, two people. Two people. Okay, so let's try doing father and daughter. Here it is. Father's height to daughter's height is 8 centimeters to 6 centimeters. Another way you could represent it is 8 to 6. Now, the ratio of father to daughter should not change whether it's picture or real life. Right? Whether it's a snapshot in space or comparing between each other in real life, it's not going to change. And so the ratios should be the same as well. The father's actual height is 1.8 meters. And if you're feeling like, oh, that's going to confuse me, if you want to do 1.8 meters in centimeters, it would be 180 centimeters to something. And I'm not going to do a question mark, please. This is math class. We're going to do x. It's an unknown. So right now, it's 8 to 6 is the same as 180 to x. So how do we solve it? I'm hoping you'll get the algebra. One method. Not multiply. So now it becomes a little bit funky, right? Like, how do I get, so ultimately, my goal is to get x all alone, right? At the bottom, at the end of the entire sentence, it's like, what does x equal to? There's a couple of ways you can do it. But a lot of it does involve just some like logical reasoning, like, okay, what do I multiply to get 180? That same number I'm going to multiply, right, to get to x. But again, I want to push algebra onto you because it's going to be helpful for a lot of other things other than just proportional. It's going to help you with the rest of mathematics. And so here it is. You know what? Yeah. How about I do it this way? Would you prefer that the x value be in the numerator? Does anyone have a burning desire or anything like that? Does it make it easier? It is. So how about this? Because we're going to deal with fractions and get rid of fractions and stuff like that, if I have a ratio of father to daughter, what's the ratio of daughter to father? But it's going to be 6 to 8, right? So how about I change this? So I'm going to, again, you can put a little line here if you want to, right? If I did daughter to father, see if I could find some more space down here. Yeah. And move this up. If I did daughter to father, it would be 6 over 8 is equal to x over 180. That's going to help us a lot more. Everyone follow me so far? I realize I should have done this in the first place. Yes. Because the father's height is 1.8 meters, which I converted to 180 centimeters first. Now, I want x all alone. What's happening to x right now? It's being divided by. So what's the opposite? Yeah, I'm going to multiply both sides by 180. What do you mean? What? Just now? Oh, I must have misheard you. I think no. You're allowed to multiply by 180. I know what you're saying. Multiply by 180 because now it's in the denominator. My goal, so it's not 8 over 6 times 180. 6 is on top, 8 is on the bottom, x is on top, 180 is on the bottom. So I'm dividing by 180, and so I want to get x all alone. If I have this division of 180 and I am multiplying by 180, they will essentially reduce themselves and turn into just 1. So we only have x on the right side. On the left, 6 divided by 8, but multiplied by 180. Plug all of that into the calculator, and you should get, let's see, here, 4, divide that by 4 times 3, divide that by 4, that becomes 45 times 3, 135? 135. Remember, this was centimeters to centimeters, this is centimeters to centimeters. It only makes sense. So we have, therefore, the daughter is 135 centimeters tall. If you like, but they are equal. 1.35 and 135, as long as the units are consistent. Oh, I solved this. You just put them in the calculator. Right? So you do 6, divide that by an 8. That looks like a percent. 6, divide that by an 8, multiply by 180 is what that is. If you didn't, good question. You would have to do a little bit more work because the x is in the bottom, right? I would do the same thing, but it takes a couple more steps. May I? For everyone else who might not be interested, bear with me. It's a really good question, so I want to answer it. Oh my gosh, why is this not registering? Okay, ready? I don't want to deal with that fraction. Just like how I was multiplying by 180, I don't want any fractions there. I'm going to multiply both sides by x. Get the denominator out. When I do so, on the right side is 180. On the left side, I have 8x divided by 6. I still want x all alone. So how about I multiply both sides by 6, leaving me 8x, and this would be 1080. And then I divide both sides by 8. to get X all alone. The whole goal, again, although the number of steps might increase, my goal does not, and that is to get X all alone. Let's try it again. This time I'm going to do most of it. I'm going to ask you to do the final calculations. Here we go. A bike is in 4th gear. When the pedal turns, oh, careful, when the pedal turns 3 times, the rear wheel turns 9 times. When the pedal turns twice, how many times does the rear wheel turn? How about I color code this to make sense of it all? When the pedal is 3, the wheel is 9. If the pedal is 2, what's the rear wheel? So it sets up the ratio for you. Again, I don't mean to confuse you, but I have to be honest. I could do blue to red equals blue to red as my ratio. I can also do blue to blue must be equal to red. Any of these ratios are okay. But Angus, just because you've been participating, let you take the next one. If you were doing this question, what 2 numbers would you put next to each other? Blue and red. So pedal turning, wheel turning, pedal turning, wheel turning. So my ratio of pedal to wheel is what I'm going to use. In this particular case, I have, you know what? I'm going to catch myself. Wheel to pedal. Wheel to pedal is what I'm going to do. And you'll see why. It does not matter. You can do red to blue, just as you can do blue to red, right? So wheel to pedal. When the wheel turns 9 times, the pedal turns 3 times. That's going to be the same as if the pedal turns 2 times, how many times does the wheel turn? So again, I'm going to convert that into fractions. 9 to 3 is the same as X to 2. And recall, I have to reiterate, I did the wheel first, not the pedal first. Okay, so maybe that color coding will help you. I know the question gave you the number for pedal first, but you can set it up in whatever order you want. Now, algebra, I want X all alone. What's happening to the X right now? What's happening? So this is the X. What's happening? What is this? What does this represent? What operation? Something about it too. You got a 25% chance, right? Adding, subtracting, multiplying, dividing. What's happening? It's dividing. It's dividing. So this is X divided by 2. And so we need to do the opposite. I'm going to multiply both sides by a 2. In doing so, these 2's will reduce into 1. It becomes negligible, right? It just becomes nothing. 19 times 2 divided by 3, you can plug that into the calculator. You will get 6. So, no, sorry, 9 times 2 divided by a 3, or 9 divided by 3, and the answer times 2, the answer is a 6. Therefore, if pedal turns twice, the rear wheel turns 6 times. Yes, Ed?
Just making sure it doesn't matter if 50% actually equals 6, it doesn't matter.
Correct. You know what? The other Mr. Kim in science will hate me for this if I don't. Mathematically, this is the proper way to write it. The variable comes first. So I should reiterate that. He has made a point to let me know, because he's in science, right? And I'm half science, half math. It really sort of like, grinds him. So if you ever have the other Mr. Kim for science in the future, maybe grade 10 or whatnot, let him know that you're going to work hard to make him happy. All right. Any questions?
Why does it say the R?
Oh, sorry, the rear wheel. I got lazy writing. I'm terrible with the therefore statements. Even as a kid, I felt like it was a waste of my time. Therefore, if the pedal turns 3 times, the rear wheel turns, sorry, 2 times. 2 times, the rear turns 6 times. There you go. And so by proportional reasoning, as long as you have some fraction equaling some fraction, you can solve it in any moment's time. And that's going to be the bread and butter for a lot of your assignment parts in Wednesday and Thursday. Okay, let's move on to the next part. How many more examples do we have here? Let's keep going. Okay. Yeah, we should be able to finish a good chunk of this by the time before the end of class. We have lots of work to do on your own. Great. The driving distance from St. Marie to North Bay, 425. Please note the hint. This particular example might come in handy a little bit in the future. On a map, this distance is scaled as 8.5 centimeters. On the same map, the distance from North Bay to Windsor is 13.5. What's the actual distance? So once again, if you have a highlighter, by all means, see if you can match the numbers. So St. Marie to North Bay is 425. Red, and then on the map, it's 8.5. The distance from North Bay to Windsor is 13.5. What's the actual distance? So again, you can do blue to blue and then red to red. You can do real life to real life and then map to map. What would you do? Somebody else. What would you want to set up your fraction as or your ratio as? Right? Real life to map, or real life, map to map. It's up to you. Pixie, was that a hand? No? It's totally up to you. Sabri, you got a hand for the other one. Do you have a preference? Well, choose then. Color blue to blue or blue to red? Blue to red. That's all you need. Just make a decision. So if it's blue to red, that means, so Marie to North Bay is my blue, and then North Bay to Windsor is my red. And so on the map, I have 8.5 centimeters to 13.5 centimeters versus in real life, how about I do this? Equals, in real life, it's going to be 425 kilometers to, I don't know. Okay. Now, by fraction, I have 8.5 to 13.5. That's a centimeter to centimeter equals 425 kilometers to x kilometers. And you probably don't want the x value on the bottom. And remember, these are representing ratios. So if these two are equal to each other, you can just as confidently say that the reciprocal of one fraction will equal the reciprocal of this fraction. They're both correct. Right? It's only a matter of, do I write Sault Ste. Marie first to North Bay? Sorry, Sault Ste. Marie to Windsor, or do you write Windsor to Sault Ste. Marie? I guess it's Sault Ste. Marie. Sault Ste. Marie. Sault Ste. Marie. Right? So let's do it. I'm going to show the work now. So we have 13.5 to 8.5 is equal to x over 425. I want x all alone because that's what the question is asking for. What's the opposite of division of 425? By now, I'm hoping. Yeah, good. That's it. So x is all alone, right? Because this is going to equal to 1. And you plug that into the calculator. I cannot do that in my head. $13.5 divided by 0.5 times 425. That is 675. And remember, this is kilometer to kilometer. And so x is 675 kilometers. Therefore,
Why do you always process the number that multiplies?
it is because they are dividing each other out. So if I have 425 multiplied by 425 over 1, if you do that as a fraction, you multiply across, correct? So you have yourself 425x over 425 times 1. Sooner or later, what happens? These two numbers are going to divide into 1.
So it'd be the same.
It's always going to equal 1 every time. Okay? That's why I do it early, because I know what's going to happen later on. So we got 625. V, distance from North Bay to Windsor is 675 kilometers. And that's pretty much it. That's all we need to worry about. Snimi? To you? Okay. And that's it. What I'm going to ask you to try to do for the next example, if you look at the back page or the second page, sorry, the back of the first page, sorry about that. There's an A question and a B question. I'd like you to try to complete this in 5 minutes. Give that a shot. I'm so confused. All right. Okay. I'm going to pause this video here and I will have the answers together up on the board so you can double check. But the rest of class is yours to do. Actually, you know what? You're right. It's the back page. There are 4 questions. How about I give you until 1:15 to try them on your own? We'll take them up very quickly together. And then the rest of class is yours to see, use as you see fit. Okay, so you got 20 minutes. I will pause that video and away you go. Okay, so once again, I think it's most prudent. If you look at the answer key that I put online, all the other questions are relatively straightforward. You should be able to follow it. However, the very last one is something I do want to spend a little bit of time on just to make sure that, you know, even if you do look at the answer key, you won't get confused. So I will color code this. They want to mix concrete to a walkway. Here we have 2 parts cement. We have 3 parts sand. And I'll use green for 4 parts gravel. Okay, and so I'll write it down as well. We have 2 parts cement, 2C, 3 parts sand, 3S, and 4 parts gravel. I'll just call it, no, that might confuse you. All right, here we go. Oops. 2 parts cement, 3 parts sand, 4 parts gravel. They only give you sand. So we have, I don't know, 4, 2, I don't know. How much cement and how much gravel should mix with the sand? So there are the 2 colors. I am trying to look for my blue. That's right here. I'm also trying to look for my green, which is right here, because they give you the red. So to set this off, we haven't really learned how to compare a fraction with 3 numbers. In fact, having a fraction on top of a fraction will only cause to confuse you. My recommendation is do what you already know with just two numbers. If I give you this, 2 to 3, you should be able to solve this, x to 4. So cement to sand is the same as cement to sand. Now, doesn't that look familiar suddenly? Multiply both sides by 4. And here we have 8/3 equals x. Done. Throw that in the calculator, you'll get 2.666 repeating. And so that is approximately 2.6 repeating meters cubed of cement is needed. And so I guess what I really wanted to reiterate for this question is stick to what you know, choose two numbers to compare, and then go with it. For the second question, I'm looking for gravel. So let's use the numbers that they give you. The ratio of sand to gravel is 3 to 4. And the question that they give you is going to be 4 to y. So again, if the ratio is 3 to 4, that is going to be the same as 4 to y. And what's y? It's in the denominator again. So I am going to rewrite this. Instead of writing it sand to gravel, I'm going to write it as gravel to sand. That is 4/3 is the same as y to 4. Why not, right? It just makes life easy for us. And again, these are just based on ratios. So instead of saying 1 to 2, just say 2 to 1. It's okay. And so I will multiply both sides by 4. It should look familiar by now. Y is 16/3. You plug that into the calculator. Therefore, 5.3 repeating meters cubed of gravel is needed. That's it. But again, it might look a little funny, but the setup, the question, the calculations, they are just repeats again and again, putting two fractions together. I hope it doesn't look daunting and that you will, however, not underestimate this. You get your practice done, do the homework, and call it a day. The questions on the back of this sheet, the homework questions are, formatting is a little weird. There's like number 1, and then the question is above number 1. There's number 2, and then the question is above number 2. I hope you can match the number with the question. The answers are already there for you. Are there any concerns before I set you free? Yeah, no, but if you look at the homework section, the question number is like on the bottom of the actual question. Do you see it? It's like the question is here, and then it's labeled as number 1 on the bottom left corner of the question. So don't be confused by it. That is number 1, number 2, number 3, number 4, and 5. Okay, I'm going to pause this or stop this video here, and the rest of class, would you please work on? Again, if there's too many questions, do every other, but do not leave this until last minute. Okay.